Rearrangements involving electron deficient oxygen. An important example of such reaction is Baeyer-Williger rearrangement. Baeyer-Williger rearrangement ketone on treatment with peracid gives ester by oxy insertion. Reaction is catalyzed by the presence of acid catalyst. Reaction is particularly useful for the synthesis of lactones. Mechanism. In the first step is the addition of peroxyacid to the carbonyl carbon leading to the tetrahedral intermediates. In next step, a concerted migration of migrating group and loss of carboxylic acid provides the product. The mechanism is supported by the fact that oxidation of PH2C18O yields only PHC18OOPH. There is no scrambling of 18O labeled in the product ester. The loss of carboxylates and migration of R is concerted, as the reaction is known to be faster when the electron withdrawing group substituents are present in leaving group and the electron donating substituents in the migrating group. If migrating group is chiral, then stereochemistry is retained. Migratory group is unsymmetrical ketone is as hydrogen, then tertiary compound, then cyclohexyl, then secondary compound, then benzyl, then aryl, then primary, and then methyl. In case of aryl group, migrating ability is increased by electron donating groups present on the ring. Following is an important example. We can see there are two types of migrations, but the most one is shown as 71%. The migration is favored when migrating group is antiplanar to OO bond of leaving group. This is known as primary stereoelectronic effect. Antiplanar alignments of electron pair of electrons on oxygen with migrating group is termed as secondary stereoelectronic effect. We have another example here. In case of unsaturated ketones, epoxidation is likely to be a competitive reaction, but Baeyer-Williger rearrangement is favored because ring strains can be relieved by oxy insertion and ring expansion. Chemoselectivity of oxidation of beta-lactam aldehyde has been achieved with MCPBA in DCM, where only formates are formed in better yield. One of the most important synthetic use of BV reaction is found in the synthesis of L-DOPA, which is a drug used in the treatment of Parkinson's disease.